Hello friends. So in the last video, okay, we have gone through the new concept, that is continuity. Okay, so in that continuity, I told you the definition. Okay, for the two functions, one is for simple function, and another definition is for what? The function which is defined in the form of less than and greater than. Okay, so the first definition is what? For the simple function, that is limit. I'll write it. Okay, that is limit x tends to c, f of x is equals to f of c. This is your first definition. So this definition, when we have to use it? When we are dealing with the simple examples like f of x is equals to x square or f of x is equals to 2x. For such functions, we will have this formula, okay, to check the continuity. Okay, whereas if you are having the function of this form, for example, f of x is equals to x, if x is greater than equals to 0, f of x is minus x if x is less than 0. If you observe here, the function is defined in the form of greater than and less than condition. Okay, so for such type of functions, you must use the second definition, that is what? LHL and RHL. Okay, actually it is left continuous function and right continuous function, but we use the definition of what? That is left hand limit and right hand limit only. So what is that? Limit x tends to c minus f of x is equals to f of c. Okay, whereas RHL is what? Limit x tends to c plus f of x is equals to f of c. Okay, so here c minus and c plus, what it means here? C minus means we are using LHL, c plus means what? We are using RHL. Okay, but one thing you have to remember here, might be I have explained in the first video also. Here, suppose now this x tends to c, it means what? In the place of x, we have to substitute this limit point. Okay, but you should not substitute minus c, you have to substitute only the c. This minus and this plus is just the notation for LHS, sorry, that is LHL and RHL. Okay, so let us have the example to check the continuity of some of the functions. So see, in this video I am going to teach you only the three questions. Okay, if you understood those three questions, then I don't think so that you will get any difficulties in the exercise. Okay, because what I am going to solve the three questions based on the similar type you may having other examples. Just the thing is what? You may have different type of functions. Okay, so let us have the first question. So f of x is equals to 2x plus 1 at x is equals to 1. At x is equals to 1. So here they have given one function, that is 2x plus 1. So you have to check the continuity of this function at continuity point, that is x is equals to 1. See this at x is equals to 1. This is called as a continuity point. Okay. So now, this is a simple function or the function which is defined in the less than or greater than. So as I told you, if it is defined in the form of greater than and less than, then only you have to use the definition is LHL and RHL. If the function is not defined in the form of this, then it is called as a simple function. For that we use the first definition. Okay, that is limit x tends to c, f of x is equals to f of c. Okay, now here what we have is c. Okay, that c value means what? That continuity point, whatever it may be, that continuity point. Okay, so first we have to find f of c here. But as I told you, c is what here? 1. So f of 1, so which is equals to, okay, you have to find out the value of this f of 1. But how to find? See, what is your f of x? 2x plus 1. Okay, if you compare this both, see here it is x, but in the place of x, what we are having? 1. Okay, so when it is x, the function is 2x plus 1, but now it is f of 1. The x place is taken by 1. So therefore, in the function also, wherever you find x, in the place of x, you have to put the value is what? 1 only. Okay, so let us put that x is 1 here in the function, that is 2 into 1 plus 1. So which is equals to 2 ones are 2, 2 plus 1 is 3. Okay, so 3 is the answer. And you have to find out limit now. So limit x tends to c f of x, which is equals to limit x tends to c. C means what here? 1. That is x tends to 1. F of x means what? Function. That is 2x plus 1. So which is equals to, now here x is tending towards 1. It means what? You have to put the x value as 1 here. So again in the function wherever x is there, you have to put 1. So it becomes what? 2 into 1 plus 1. Again the answer is 3. So if you observe, f of 1 value and limit value both are same. So therefore what? Limit x tends to 1 f of x is equals to f of 1. So this both the terms are equal. If they are equal, then you have to conclude what? F is continuous function. F is continuous function at x is equals to 1. In case if any one of the example, suppose after finding this both the values, and if you are getting not equal, then you have to conclude that f is not continuous, or another word for that is discontinuous at that particular point. Okay, so this is one example, one pattern you can say, one type of example I have solved here. Okay, what is the type of this example? Pattern of this example, that is function is simple and continuity point is given. Function is simple and continuity point is given. Okay, now I will take second type of example. Okay, that is, so I will take the example is f of x is equals to mod x at x is equals to 0. At x is equals to 0. So you have to calculate the continuity, or you have to check the continuity of this mod x function at x is equals to 0. So in the first year relation and function topic, you have studied the types of functions. Okay, if you remember, okay, that is signum function, greatest integer function, modulus function, is it? Okay, so one among that is what? Modulus function. But as you know, what is the application or what is the job of that modulus function? Always it converts the negative quantity to what? Positive quantity. Negative quantity to what? Positive quantity. Okay, so therefore this modulus function always having two values, that is plus and minus. So therefore how it is defined? So f of x is equals to, okay, f of x is equals to mod x value is plus x if x is greater than or equal to 0, mod x value is minus x if x is less than 0. Okay, so this is your function now. To check the continuity of modulus function, don't use this. If you use this, okay, that is not a proper way. Okay, so first that modulus function you have to represent into the other form. Okay, and then you have to check the continuity. But what I said, this is not a simple function now, because it is defined in the form of greater than and less than, and for that we have to use which definition? LHL and RHL. Okay, so while finding LHL and RHL, before that you have to find f of c again as usual. So let us find f of c, but here c is what? 0. So f of 0, which is equals to, now f of 0 meaning is what? Equals to 0. Okay, x is equals to 0, because in the place of x I am having this value, so therefore x is equals to 0. So in the function we have to check where is the equal sign. Okay, if you observe here it is just less than, but in the first condition if you observe here greater than also there as well as equal sign also there. So wherever the equal sign is there, that function you have to take it. Okay, so for equal to 0, what is the function? X. But what is your x here? 0. What is your x here? 0. Okay, now you have to find LHL. What is the definition? I think I have written there. Limit x tends to c minus f of x, which is equals to limit x tends to c minus c is 0, so 0 minus. Okay, now here what f of x you have to take. See, one more thing I will tell you. LHL means less than, RHL means greater than. LHL is less than, RHL is greater than. So I am using LHL. So LHL means what? Less than. So for less than 0, function is what? Minus x. So it is minus x, which is equals to. Now you have to put the limit is what? X tends to 0. See, I told you that this minus sign is just a notation, but while putting the value of x, you have to put it only that number. Okay, so x is tending towards 0, so x is what here? 0. So I think we will get minus 0, but as we know 0 is a neutral number. Okay, if you write minus or plus, having the same meaning, so I will write just 0. Okay, then I am having second formula, that is RHL. Definition is limit x tends to c plus f of x, which is equals to limit x tends to, I am going to put the c value here, that is 0 plus f of x function, right? RHL means what? Greater than. So for greater than 0, f of x is x here, that is x. Now put the limit is x tends to 0, so x is 0 here. Okay, now if you observe here, f of c, LHL and RHL, check their values. 0, 0, 0, all are equal, all are equal. So I will conclude, therefore LHL is equals to RHL is equals to f of 0. So when this all the three terms are equal, then our conclusion is f is continuous. F is continuous function at x is equals to 0. At x is equals to 0. Okay, suppose if it is not equal, again as usual our conclusion is what? F is not continuous function or discontinuous function. Okay, so this is the second type of example or second pattern example. I will teach you one more example. Okay, that is, now what I taught these two examples here, which is having the continuity point, okay. I am having two more examples here, okay, that is with simple function and this greater than and less than function. Okay, what I have solved these two questions, that is for continuity point. They have given the continuity point. Suppose if the continuity point is not mentioned, okay, then how to simplify that example? Okay, I think that two example I may take in the next video. Okay, so please you go through this video. Thank you.